All right, welcome back, everyone. We're ready for another deep dive. And this time we're tackling something that's on everyone's minds this time of year: climate regions.
Definitely a hot topic.
You got that right. So many people get intimidated by geography, but I think climate is actually a really cool place to start.
It's true. It's something we all experience every day.
Exactly. Plus, let's be real, understanding how climate works is becoming more and more important these days.
Absolutely.
So we've got your notes here, which, by the way, are incredibly thorough. Seriously, you've got definitions, diagrams, even a whole section on South Africa's climate.
I like to be prepared.
Yeah, you definitely went all out. So before we get too far ahead of ourselves, let's start with the basics. You've got a definition for climate right at the top of your notes. Want to refresh our memory?
Sure. Climate is basically the long-term average weather patterns for a particular region, usually observed over a period of 30 years or more.
Right. So we're not just talking about whether it's sunny or rainy today, but like the overall long-term trends of temperature, precipitation, wind, all that good stuff.
Exactly.
And then you've got climate regions, which are basically areas on Earth that share similar climate characteristics. It's kind of like the planet's way of organizing itself into different climate zones.
Exactly. Think of it like this. Rainforests all have a certain type of climate, right?
Yeah.
And deserts have a different type of climate.
Right, so we're grouping together places that have similar long-term weather patterns. Okay, that makes sense. Now let's talk about what actually influences these climate patterns. We've got five main factors listed in your notes: latitude, distance from the sea, altitude, ocean currents, and mountains. It's like each one of these is a piece of the puzzle, right?
Absolutely. And they all work together, sometimes in surprising ways.
Mhm.
But sometimes one factor can really be the dominant influence. Like you could have two places that are at similar latitudes, but if one is high up in the mountains,
It'll be way colder.
exactly. So even though latitude is a big factor in determining climate, those other factors can really shake things up.
I like that. Shake things up. It's like they add all the flavor.
Right.
So we've got these five factors: latitude, distance from the sea, altitude, ocean currents, and mountains. Which one do you want to tackle first?
Let's start with latitude, since it's often considered the most important factor.
Okay, latitude it is. Now, I know latitude has something to do with how far a place is from the equator, but how does that actually affect the climate?
Good question. So basically, the Earth is tilted on its axis, right?
Right.
And that tilt means that different parts of the Earth receive different amounts of direct sunlight throughout the year. The areas closer to the equator, they get the most direct sunlight, so they're generally warmer.
Okay, that makes sense. So the closer to the equator, the hotter it tends to be. And as you move further away from the equator towards the poles, it gets colder.
Exactly. And it's not just about temperature either. Those variations in solar radiation also influence things like air pressure, which in turn affects wind patterns and precipitation. It's all connected.
Wow, it's like this domino effect, starting with the Earth's tilt and then influencing all these other aspects of climate. I'm already starting to see how complex this all is.
It definitely is, but also incredibly fascinating, would you say?
Totally. Okay, so we've got latitude, setting the stage, influencing temperature, air pressure, all that good stuff. What else should we know about how latitude impacts climate?
Well, let's talk about those wind belts for a second. Have you ever heard of the trade winds?
Maybe. They sound like something out of Pirates of the Caribbean, to be honest.
Uh-huh. Well, they are kind of adventurous. Basically, the trade winds are these massive wind patterns that blow consistently towards the equator. They're driven by those differences in air pressure that we were just talking about, which are caused by, you guessed it, latitude.
So it's like this chain reaction again. The Earth's tilt causes differences in solar radiation, which affects air pressure, which creates these giant wind patterns.
Exactly. And these wind patterns, they don't just blow around aimlessly, they carry moisture with them. So understanding where those trade winds blow and how they shift throughout the year helps us understand things like rainfall patterns around the globe.
Oh, that makes sense. So latitude is like this behind-the-scenes director influencing temperature, air pressure, wind patterns, precipitation. It's a lot to keep track of.
It is a lot, but it's like a giant puzzle, and we're starting to put the pieces together.
I'm ready for the next piece. What other factors should we add to our climate puzzle?
So next up on our list of climate VIPs is distance from the sea. Because being near a massive body of water, that definitely impacts your local climate.
Oh, yeah, for sure. It's like those coastal cities always seem to have that nice, mild weather.
Exactly. Water, it's like a giant temperature regulator. It heats up and cools down a lot slower than land does.
Ah, that makes sense.
So coastal areas, they tend to have more moderate temperatures, not those wild swings you see further inland.
Okay, so basically the ocean is like a giant AC unit in the summer and a giant space heater in the winter.
Pretty much. And, you even included a little formula in your notes for calculating the average high and low temperatures based on distance from the sea. Like, you were serious about those details.
What can I say? I like to be precise.
Okay.
But yeah, that formula shows just how big of a difference distance from the sea can make.
Yep.
Okay, so we've got latitude setting the stage, distance from the sea moderating those temperatures. What about altitude? We can't forget about those mountain climates.
Absolutely. Altitude is another one of those factors that can really shake things up.
Because even if you're in a generally warm region, if you go high enough, you'll hit those cooler temperatures.
Exactly. And you've got a great note here about how temperature tends to decrease with altitude.
Let me find it. Here it is. For every 100 meters you go up, the temperature drops by about 0.6 degrees Celsius.
Nailed it.
Yeah.
So even if you start out in a tropical rainforest at sea level, climb a mountain, and you might find yourself in a completely different climate zone.
That is so wild. Okay, so altitude, definitely a game changer. What's next? Ocean currents. Those always seemed kind of mysterious to me.
They do have that air of mystery, don't they? But trust me, they're major players in the climate game. Think of them like giant conveyor belts moving warm and cold water around the globe.
Okay, so how does that actually affect the climate in different regions?
Well, your notes specifically mention the Agulhas and Benguela currents, which are super important for South Africa's climate.
Right, I remember highlighting those. They sound more like characters from a fantasy novel than actual currents.
I know, right? But they're real and they have a huge impact. So the Agulhas current, that's the one that flows down the east coast of South Africa. It brings warm tropical water from the Indian Ocean.
Ah, so that's why Durban is so warm and humid. It's basically getting a constant dose of tropical paradise.
Exactly. The Agulhas current is like Durban's personal spa, keeping things warm and pleasant. But then on the west coast, you've got the Benguela current, which is a completely different story.
Yeah, the Benguela Torrent. That one always sounded kind of ominous to me for some reason.
Well, it is a bit chilly. You see, the Benguela originates in the cold South Atlantic, so it brings up all this chilly water along the west coast of South Africa.
That explains why the West Coast is so much cooler and drier than the East Coast. It's like two totally different worlds.
Precisely. And it's all thanks to those ocean currents.
Ocean currents, they're small but mighty. Okay, we've covered latitude, distance from the sea, altitude, and ocean currents. What about mountains? They're hard to miss, so I'm guessing they play a role too?
They definitely do. Mountains, they're like the drama queens of the climate world, always making things interesting.
I like that. How so?
Well, for starters, they create something called a rain shadow. Have you ever heard of that?
Maybe. It sounds familiar, but refresh my memory.
Okay, so picture this. You've got moist air coming in from the ocean, full of moisture, ready to rain.
Okay, I'm picturing it.
Now, as that moist air hits a mountain range, it's forced to rise.
Makes sense. Mountains are not exactly easy to go around.
Exactly. So the air rises, and as it goes higher, it cools down.
Okay.
And here's the key. Cold air can't hold as much moisture as warm air.
Ah, so as that moist air cools down as it goes up the mountain rim.
It dumps all that moisture as rain. So you get lots of rain on the windward side of the mountains, the side facing the wind. But then that air, it's wrung dry by the time it reaches the other side of the mountains, the leeward side.
Creating what's called a rain shadow. It's like the mountains are casting a dry spell on the other side.
Exactly. And that's why you can have lush rainforests on one side of a mountain range and then a desert on the other side.
That is so cool. Mountains are like the ultimate landscape architects,
Yeah.
shaping entire ecosystems with their rain shadows.
Absolutely.
Okay, so we've covered a lot of ground here. Latitude, distance from the sea, altitude, ocean currents, and mountains. Those are some powerful forces shaping our planet's climate.
They really are. It's like this intricate dance between all these different factors, and it creates such a diverse and fascinating range of climates.
It's mind-blowing when you think about it. And speaking of mind-blowing, we still haven't even touched on climate graphs.
We haven't. Those
Yeah.
are up next, ready to decode those visual representations of climate.
You know it. Bring on the graphs. All right, so before we go globetrotting to all these different climate zones, let's do a quick recap. We've been talking a lot about climate, but your notes also mention weather. What's the difference again?
Right, so weather refers to the short-term atmospheric conditions in a specific place and time. It's like, what's happening outside your window right now? Is it sunny? Is it raining? Is there a tornado? That's weather.
Okay, so weather is like the here and now. It's what we experience on a daily basis, but climate is more like the big picture.
Exactly. Climate is all about those long-term patterns and trends in weather over a much longer period, usually 30 years or more. It's like taking all those daily weather snapshots and putting them together to see the bigger picture.
Got it. Weather is the snapshot, climate is the whole photo album. Makes sense. Now, even though we're focusing on climate, you still have a section in your notes about the elements of weather. You've got temperature, precipitation, humidity, and wind. I guess those are still important, even when we're thinking long term, right?
Absolutely. Those elements, they're like the building blocks of
Mm.
both weather and climate. And they're also the things that we experience most directly in our lives.
Mm.
Like think about how temperature and precipitation influence what kind of clothes we wear, what crops we can grow.
Right, whether we need an umbrella or a snow shovel.
Exactly. So even though we're talking about long-term climate patterns, those individual elements of weather are still super important for understanding how climate impacts our lives.
Okay, that makes sense. Now, let's dive into those climate categories you have listed. You've got tropical, desert, Mediterranean. It's like a global climate buffet. Where should we start?
Let's stick with our trusty latitude for a moment because it really sets the stage for these major climate zones. As we've discussed, those areas closer to the equator, they're generally warmer, right? So that's where you'll find your tropical climates. Lots of sunshine, warm temperatures year-round.
Think rainforests, beaches. Sounds pretty ideal to me.
It does have a certain appeal,
Yeah.
but even within the tropics, there's a lot of variation. Some tropical regions are lush and rainy all year, while others have distinct wet and dry seasons.
Oh, right. Because it's not just about latitude, it's also about those other factors we talked about.
Right.
Distance from the sea, ocean currents, all that good stuff.
Exactly. So you can have a tropical rainforest on the coast of Brazil, and then a tropical savanna with a distinct dry season further inland. Same latitude, but very different climates.
Climate is so much more complex than I realized. Okay, what about deserts? I always picture those scorching, hot, sandy landscapes.
It's true, a lot of deserts do fit that description. But did you know that Antarctica is technically a desert?
Wait, really? Antarctica?
Yeah.
But it's covered in ice and snow.
Exactly. But the key thing about deserts is that they receive very little precipitation. And Antarctica, believe it or not, gets very little precipitation in the form of snow or rain. It's incredibly dry.
Wow, that totally blows my mind. So a desert isn't just defined by its temperature or what it looks like, but by how much precipitation it receives.
Precisely. It's all about that lack of moisture.
Okay, I'm definitely going to need to rethink my whole desert perception. What about Mediterranean climates? I feel like I have a pretty good grasp on those, what with the sunny beaches and all.
It's true, the Mediterranean region definitely sets the standard for that classic Mediterranean climate.
Mhm.
Those hot, dry summers and mild, wet winters. But it's not the only place with that perfect combo. Think of California, parts of Chile, even southwestern Australia.
Wait, seriously? I always thought those places just had like really nice weather. I didn't realize they were technically Mediterranean climates too.
They are. And again, it all comes down to those specific combinations of factors we've been talking about. Latitude plays a role, but so do ocean currents, the presence of nearby mountains, all of it.
It's like every climate is a recipe, and it's the specific combination of ingredients that gives it its unique flavor.
I love that analogy.
Okay, one last thing before we wrap up. Climate graphs. You know I love a good visual aid, and those graphs look pretty intense.
I know, they can seem a bit intimidating at first glance, all those lines and bars. But trust me, they're incredibly useful for visualizing all these climate patterns we've been talking about.
Okay, so how do they work? Walk me through it.
Okay, so typically a climate graph will have temperature represented by a line graph and precipitation represented by a bar graph. And they're both plotted against the months of the year, so you can see how those elements change over time.
So you can see those seasonal variations, like when it's hottest, when it rains the most, all of that. It's like taking all those climate concepts we've been discussing and turning them into a visual story.
Exactly. And the cool thing is, once you understand how to read a climate graph, you can quickly get a sense of a region's climate just by looking at those lines and bars.
Okay, that is pretty cool. So we've gone from latitude to deserts in Antarctica to climate graphs. My brain is officially full of climate knowledge.
You've got those incredible notes to thank for that.
They are pretty amazing, I have to admit. I feel like I've gone from climate novice to like at least a climate apprentice today.
You're well on your way to becoming a climate master. And remember, understanding climate is not just about memorizing facts and figures. It's about appreciating the incredible complexity and interconnectedness of our planet.
That's a great point. It's about seeing those connections between the Earth's tilt, those wind patterns, the ocean currents, even those mountains casting their rain shadows. It's all connected.
Yeah.
Exactly.
Mm.
And the more we understand those connections, the better equipped we'll be to appreciate and protect this amazing planet we call home.
Couldn't have said it better myself. Thanks for taking this deep dive with us. Until next time, keep exploring.